Hey everyone, welcome back to ML Works. In this video, we'll learn how to build a SQL agent using LangChain. So with the help of this agent, you will be able to answer questions related to your SQL database in natural language. So what happens when you send a natural language query to this agent? So first, it will fetch the relevant tables and schema from the database, and it will try to generate a SQL query. And it will execute that query and see if it is able to get the response. If it is throwing an error, then it will go back and refactor the query and execute it again and get the results. So with that, let's jump to our tutorial here on SQL Agent. So first, I have created an environment for the specific tutorial, which is deep agent-env. And as part of the first step, we'll be installing the packages which are required for running this specific tutorial, which is LangChain, LangChain Community, and LangGraph. So let me install those. So it is already installed, so I have commented that line. So you can go ahead and install it in your environment. So once that is done, what we'll do is we'll load the API key, which is represents the Gemini model. So it is stored as part of env file here, and what we'll do is with the help of this specific library load_.env, we'll be loading the .env file into this runtime environment. So let me run this. So it is loaded now. Next step is to select an LLM. So you can either use OpenAI LLM or any other LLM. For now, I'll be using Gemini because it is free version that I'm using. And here I am loading the API key, and then I am setting out the model here, init chat model, which is Gemini 2.5 Flash. So once the model is selected, next what we do is we configure the database. So first we'll be setting the URL where the database is stored, and then we create a local path for the same database. Next, we check whether this database is present in a local path or not. If it is not present, then we go to the specific URL and download it and store it. So with that, we configure the database. Next step is to create a LangChain wrapper to interact with the database. So we'll be loading from LangChain community, we'll be loading SQL database. And this will result in db is equal to SQL database from URI, and this is the database which we are loading. And this will tell us the dialect and what are the different tables that are present inside this db and what is a sample input present in this specific table. We'll see the first 5 records. So the dialect is SQLite. And the available table is there are multiple tables are present, and for this from select star from artist table limit 5. So there are like 5 records from the artist table that we are selecting. Now what we can do is we can use a tool, SQL database tool, to interact with the database. So what we do is from LangChain community we import SQL database toolkit. And in this specific function or the class, what we do is we put our database, which was pulled from the previous step here, and the model that we initialized earlier, which is the Gemini model. And this will result in our toolkit, and we get our tools like mentioned here, toolkit.getTools. Let me run this. So there are a bunch of tools that are present now as SQL DB query, and input to this tool is a detailed correct SQL query. So this is where you will be sending your query, and DB schema input to this tool is a comma separated list of tables. Output is the schema and the sample rows. Then we have SQL DB list table tools, and then SQL DB query checker. So if you remember, if I have here shown here, we double check the query for common mistakes using LLM. So we'll be having this specific query checker to understand whether the query generated by this DB query is correct or not. Query checker. That's it. These are the 4 different tools that are present. So it got executed. Now what we do is we set the system prompt for the agent, and this will tell exactly what it has to do. When a natural language question comes up, it has to turn that into a SQL query, and it has to make use of all the statements that are present here, like insert, update, delete, drop. So it has to make sure of all the statements that we provided here. It has to make sure it uses those. So here what we do is, first we create this prompt, and then we format it with the help of this specific command. Dot format dialect db.dialect and top 5k. So if I just go here again, if I type system prompt, so this is how it will be showing up, the specific system prompt. Now we go ahead and create our agent from LangChain. So in the create agent, we'll pass the model, which is our LLM, the tools that we have created, which is SQL database toolkit, and the system prompt, which we just saw. So this will help us in creating our agent. Now what we do is we send a query in natural language, which genre on average has the longest tracks, and then this question will be sent to the model and we'll get our response. So if you see here, for step in agent.stream, we pass our question and stream mode is equal to values, and we'll be just printing it here. So it will keep looking for that specific answer with the help of this database query, and then it will generate the response, final response. So let me go back here. So here, first look at this one. So the first human message is what genre on average has the longest track, and it will, the tool calling that has been done here, it is to select the list data table, that is database tables. It will look into these database tables. Since it is the longest track, it will look for track, and since it is genre, so it will also take the genre table. So it will select those two tables based on the query that we have asked. And based on that, what it will do is, next, if you see, it will fetch the corresponding schema for those table. For genre table, you have these details. Similarly, for track, you have these details or metadata or schema. So using these information, you will be sending this to your LLM, and you will generate a SQL query. So this is just the 3 rows from the track table. It has nothing to do with our final query. So here, if you see, you will be checking the query, which is SQL, and here we want to get the genre name, what is the average t milliseconds, and has average track length. So this is the query checker, and once again we are going through the query checker. So this is AI message, this is tool message, again AI message and tool message. And if you see here, this is our final response. So for the genre like sci-fi and fantasy, this is the longest time track. Okay, this is the longest time track. So here you will get the final response. So the genre with the longest average track length is sci-fi and fantasy. Okay, and it is in the previous step, it has mentioned the time taken for that. So this is in milliseconds. So if I go and copy this, just copy this and let me turn it into 60 into 1000. Let's see what comes up. Okay, so this comes up around 48.5 minutes. So that is the longest track. So what we have done is, so we have able to send a natural language query to database, SQL database, and it went into the database and understood the tables that are relevant to that query, and then fetched the schema details about that table, and use that schema information along with the query that we send, which is the finding the longest track. That information along with those schema information, it generated a query, and it sent and executed that query and got the response. And finally, it generated our final response, which is the genre with the longest average track length is sci-fi and fantasy. So with that, I'll be concluding this video. Thank you for watching.